How many of you are outside of Europe? No, UK doesn't count. I was trying to find a jet lag buddy because this is, that time of the day when you really start feeling asleep. And I'm like, who is with me here? Okay, all right, so just me, and my goal is to not fall asleep while I'm presenting, which will be great. So my name is Ashish, and I'm a product manager on Azure HDInsight. And so today we're going to talk about this very profound topic when it comes to the cloud and big data. If we think about our customers run petabyte scale data warehousing systems, petabyte scale big data systems in Azure. And even change set every single day is in tens of terabytes to hundreds of terabytes. And then the fundamental question becomes, how can they analyze that data or get insights from that data without doing any ETL? Now the question is, hey, why ETL? We've been doing ETL forever, and what is this zero ETL means? So when we think about the ETL, you basically need to kind of merge one data set to other data set. Then you kind of need to convert that data into Orc or Parquet file format, and then use tools such as Spark or Hive in order to analyze that data. But imagine if you are receiving 100 terabytes of data every single day. It's just physically impossible and very, very expensive to do ETL at such a large scale. I mean, you can do it. There is no problem in computer science that you cannot solve. But it takes quite a bit of resources to do that work. And so increasingly, our customers are asking, how do I get my data is in its purest form, sitting on the cheapest commodity storage system in the cloud, but I want to be able to get insight out of the data in its purest form. And so that's what the next 40 minutes we're going to kind of focus in terms of how you can achieve that in Azure. But before I talk about LLAP and its ability to do analytics on data sitting in its rawest form, I just wanted to kind of introduce HDInsight to you guys. How many of you are already familiar with HDInsight? Okay, quite a bit. Very good. For those who do not know what HDInsight is a managed cluster service in Azure. So we provide Hadoop and Spark as a fully managed PaaS service. We deliver what we call workload optimized clusters. So you enter some details, do some clicks, and a cluster is given to you. The cluster that we give to you is fully optimized. What we mean by fully optimized, we run tens and thousands of these clusters in production for our customers every single day. And we learn from each one of these workloads and bring some of those best practices configurations back to the cluster that we give you from our service perspective. And so we always tell this to our customers, you're going to get a best performance with our default configurations in our clusters. If you change anything, and by the way, you can change a lot, in a typical Hadoop cluster, there are about 100 different configuration files. Each configuration file has about 70 different settings. So if you do your permutation and combination, right, there are about 7,000 settings that you can change, right? And a lot of people get kind of lost into that. Our recommendation to our customer is change nothing, and you're going to get your best performance from our out-of-box configuration. Then from our infrastructure perspective, we run monitoring and healing services, meaning that if a cluster is running, we're going to monitor that cluster. And when we say monitor, it's just not the physical hardware, such as maybe the storage or the virtual machines, those are running in there. But we also monitor each and every Hadoop service that is running in the cluster. So for example, we're going to be pinging Uzi endpoint, your Yarn resource manager, and all of those services. And if something goes wrong, then we run our other service in the background, which we call a healing service. And this healing service kind of goes and automatically fixes issues for our customers. And so if you think about this space, Hadoop is great. It is known to work at a very high scale. But managing Hadoop has been a challenge for a lot of our customers. we try to solve some of those most difficult problems for our customer by these type of investments. Now, delivering a Hadoop cluster and manageability is one aspect of it. But if we think about sort of various personas that deals with the Hadoop clusters, all the way from people might be writing the Spark jobs to a BI analyst who might be connecting to these systems. So we have done quite a bit of work with the community in terms of having HDInsight support within those tools, as well as invested quite a bit in our own tools. So if you go to Visual Studio Code, for example, and then if you run your Hive queries from Visual Studio Code, as well as the Python code in a Spark cluster, you could do all of that. One of the things that we recently received, and a lot of our customers like it, so we delivered a support for Spark in IntelliJ. And so what you can do is that you can write your Spark program in IntelliJ and run that program in HDInsight cluster, but have ability to hit a breakpoint, both in the driver code and in the executor code, which is amazing if you think about it, from a productivity perspective of that developer, whosoever is developing that. Then, majority of our customers are enterprise customers, so enterprise security and SLAs becomes very critical to any service that is running in Azure, and so we kind of spend quite a bit of time there. Again, if we look at this space, it's quite a big space, and it's a very nuanced space, right? Whatever you need is slightly different than what you need. And then if you go to the conferences like this or Strata or any other conference, you see a number of players in some of these booth floors, right? Because there are a lot of different ways of doing some of these things. And so we provide what we call a marketplace. It is a very curated marketplace. So let's say you created a cluster, and you needed, let's say, at scale or WAN Disco for data movement. It's just one click away. We provide that first-class experience. From a business model perspective, it's a per-minute billing. So let's say you spin up a cluster and only kept it up and running just for a minute. You're going to get charged only for 1 minute. We don't charge you any more than that. And again, our support comes with a sort of a standard Azure support. So there is no additional support contract that you need to buy for Hadoop bits. So we provide all of that. And all of that is kind of included into that per minute, the billing business model that I talked about. So this is just a little bit of in terms of how you will create HDInsight cluster. So in the Azure portal, you'll go to the data and analytics section, and there is HDInsight. Once you click on HDInsight, we present you an option, which cluster shape that you want. Hadoop for traditional Hadoop, like a MapReduce and Hive workload. Then we have a specialized clusters for HBase, Storm, Spark, R Server, Kafka. Today's focus is LLAP. We deliver that cluster shape by name interactive query because we figured out that if I'm selling this to a business person and I told them that I'm selling them LLAP, they would never buy it. So we needed a name which is more resonates with what the reality is and what the common users would do it. So we have that cluster shape by name, what we call interactive query. Then I was talking about the security. So if you enable the security package, so that means that you get integration with Azure Active Directory for your identity management and Apache Ranger for your authorization, where you can write very fine-grained access policies on your Hive tables or Spark tables. Now, the storage aspect is very important. In HDInsight, we do not use HDFS, or we try not to use HDFS. Instead, we use Azure Blob storage or Azure Data Lake Store. So these are two storage systems in Azure, which are highly scalable. Azure storage, for example, has been running since Azure was born many, many years back. And so these are time-tested. The whole planet sort of runs on these type of storage systems. They do bring some of the learnings from HDFS. For example, every time you write a file, it's already at the minimum 3 times replicated. And so one of the challenges that we see on premises is that kind of a scaling HDFS is a big challenge. All of that kind of goes away with the reliance on on these storage systems. Now, you can have a multiple storage system sort of attached to your cluster, multiple storage accounts. We don't really care. Then you pick up nodes, how big of a cluster that you want. And in this case, it's a 4-node cluster. And then it's going to kind of calculate that price for you. And this was the point that I was making about that marketplace. So you're just going to go and pick whatever application that you need. These applications get installed in an edge node of the cluster so that they have full access to the cluster. And it's just a one click away. And it's just not like an open marketplace that anybody can come. And then you need to figure out the integration and all of that. All of the integration bit is done. The moment you select something, it's ready, you're ready to go. So what do people run on HDInsight? So ETL batch is quite a big scenario for us. A lot of our customers use HDInsight for just running ETL and batch. Just to give you some example, 90% of the clusters that get created in HDInsight do not see a second day. Right? So they come up, they process the data, and they get deleted. The second use case that we see quite a bit is around sort of a data warehousing, where end users are connecting to these clusters. It could be Hive, LLAP, Spark SQL, or maybe using one of these applications such as AtScale or Apache Keylin. So data science and machine learning, we provide Spark ML, for example, as well as our server as part of HDInsight for data science and machine learning. Streaming is also quite popular scenario. We have many customers using the pipeline that I'm kind of showing you there. Data is captured in Apache Kafka, then processed in Apache Storm or Spark Streaming. Traditionally, it used to be Storm, but nowadays we are seeing that Spark Streaming is picking up quite a bit, and then storing data in HBase for the hot path, and maybe storing in storage for the cold path. And last one, I think, is a combination of all of the above, lift and shift. So a lot of our customers come from a Hortonworks SDP-based background or Cloudera-based background to us. Now, HDInsight is based on Hortonworks. I don't know if you guys are aware of that or not. So that migration becomes very easy in those cases. But today's focus, we're going to kind of talk about that data warehousing part. So one of the things that I talked about earlier was around this idea of decoupled storage and compute. So on the right-hand side, what you see is our storage system. That could be Blob Store or Azure Data Lake Store. And on the left-hand side, it's your HDInsight cluster. Now, you don't have to maintain nodes in your Hadoop cluster in order to deal with storage. On premises, we see this quite a bit. You would see that the CPU is only at 50%, but you are still adding node just to keep up with the data growth. That is not the case with the cloud, because you can always scale up and scale down those nodes. Not only you can do that, you can also mount multiple different clusters on the same storage. So you can have a scenario where on the same storage, you have just one cluster with one node mounted, or you have an n number of clusters with thousands of nodes mounted. And so cloud kind of gives you these three promises. One of them is compute is stateless and on-demand. You don't have to keep your cluster up and running all the time. Storage is cheap and limitless, so there is no limit in terms of how much of data that you can store in that limit. And network is meshed. It scales linearly with each node. So as you add more node to the cluster, it has its own bandwidth in order to talk to that underlying storage. So it scales very linearly. So in the case of the LLAP and some of the batch processing, it basically boils down to this scenario. And many times when our customers come from on-premises to the cloud, maybe on-premises they have like a 1,000-node cluster, but when they come to HDInsight, they fundamentally divide their architecture into on-demand clusters and data-serving clusters. So the on-demand clusters are the clusters who are going to do your ETL, and data-serving clusters are the clusters who are going to kind of serve the end users. And so if we look at the on-demand processing clusters, the typical workflow is, a cluster gets created, job gets submitted, output of that job gets stored into, again, the storage account, and then cluster gets deleted. Now, to orchestrate this, we give a lot of APIs for you to do it. But if you want to have a finished product, then Azure has a product called Azure Data Factory, which can help orchestrate all of this piece. We have customers who run about like a 600 to 1,000 cluster creates every single night. And they process this data, and the cluster gets deleted. It's amazing from a cost and agility perspective. Now, you're not running that cluster 24/7. You're just using it for the number of hours that you need to use. And then you can have a lot of flexibility. If two departments want to have maybe one want to run a Hive and Spark and maybe something else, you can have a lot of that flexibility. Now, if you think about the data serving clusters, now you're not sort of limited to any one technology. And we call it this data lake concept, where all of your data is in this cheapest storage system, right? That's where your data is. And your processing clusters are coming on demand and crunching the data. But on the serving side, you can bring any number of different technologies depending upon who your users are. So for example, one of the big customers of HDInsight is Xbox, one of the internal Microsoft customers. They run about 5 petabyte data warehouse on HDInsight. Now, they have a very large user population that they need to serve, or the user population that want analytics from all of this data. Some of them are data scientists, and they like Python, for example. So the Xbox team throws a Spark cluster on top of the same data, so that these data scientists can write their Python code and drive their analytics. Then there are other departments who only understand SQL, right? And so for those kind of customers, they throw a Hive or a LLAP or maybe even a Spark SQL cluster, so that they can kind of get that insights. There are new population that is coming in the organization, and they are Presto fanboys. They've heard that Facebook has done great work with Presto, and they want to kind of try out Presto. Again, all of these can go against same data and metadata and get data. So it's literally not a tool conversation. It's a data lake conversation, and how you can have multiple tools for multiple different personas, users, departments within your large organizations. And then the way people would kind of talk to all of these different tools, as I talked about, we are very focused on making these personas successful. So be an analyst, they could interact with all of this data with Power BI, Tableau, Excel, or DBviewer, very famous in open source communities. If they are a Power users, then ODBC, JDBC connectivity is there. If they are data engineer, then I talked about our investments in IntelliJ, Eclipse, Visual Studio Code, and we support Zeppelin and Jupyter for data scientists. That's great, but why LLAP? Didn't I see like a lot of options there? So if you think about the Canonical pipeline today, you ingest data. Maybe data is coming from your on-premises data sources. Maybe it's a CRM system, or it's an IoT-based system, and you're ingesting through Kafka. Once data lands in the data lake, then you, of course, transform. Then you convert data into the ORC or Parquet file format, depending upon what the engines that you might be using. And then you load into a data warehousing system, and that's how people kind of get to this data. This is amazing. This has worked for many, many years, but it's not working anymore. At the big data scale, when people are ingesting hundreds of terabytes of data every single day, that transformation is becoming very, very expensive. The conversion itself, so I was converting 100 terabyte of CSV data into ORC file format. It took me a 100-node cluster and 3 days worth of time to do that conversion. So it's expensive. It costs money. And then loading to a relational store, you could do for some set of data, and you must do for some set of data. But for all of the data, it's just very expensive to, again, load into a different system. And then between different systems, you need to manage, maintain, and operate and worry about all of that integration. How many ways you express date time, for example, and how many time our pipelines break because of that data type has changed or somebody has done something. So that is one set of problem. The other set of problem, especially in the cloud, is these remote storage systems are great, right? There is no limit in terms of bandwidth. There is no limit in terms of how much data you can store. However, there is this penalty of latency because at the end of the day, these are remote storage systems. And so the question becomes, how do you kind of deal with that? So let's try to see if I can get to the demo and show you some of these things. Can you switch me to the demo, please? Oh my. Okay. It's a little better. So I had a lot of things to show you, but given the state of affair, I'll probably scale down my demos. One demo that I specifically wanted to show you. So the cluster that you see here, it's hard to see, but it's a 4-node cluster that I'm showing you. And it's LLAP cluster in Azure HDInsight. And so this cluster is mounted on a data set which is 100 terabyte in size. And this 100 terabyte data set is derived from TPCDS. You guys know about TPCDS, right? So it's a derived data set. And so what I'm going to do, I'm going to issue a TPCDS derived query. It's called query 21. It's quite a bit of a complex query. And so in this case, my data set is in org file format. And as you can see, there are a couple of aggregations. Those are happening in there. And data is being read from 4 different tables. And then there is a group by statement as well. So it's a fairly complex query if you think about it. And then the tool that I'm using is a Visual Studio Code. As I said, we have done a ton of investments, not only for LLAP, but for our other workloads as well. So I'm just going to kind of run this code. And it's going against that database. How much time do you think this is going to take? Any guesses? All right, results are back. So if you look at it, total execution time was 4 seconds. And if I look at how much data was kind of read, so in a, let me see if I can make it. So even in a map 1, it read about 67 million packets. So quite a bit of a heavy operation, but the results came back in like 4 seconds.
Based on Azure Data Lake or Blob store?
In this case, it's in a Blob store. Okay. Now, but if you think about this org database, I did the transformation, right? I changed data from, my original data set was CSV data set. And now I changed it to the org data set. And some of you would say, that's why you are getting great performance. So what I have is, again, in the same cluster, I also have a 100 terabyte of same data set, but in this time, a CSV database, right? So this time, non-optimized, my query is going to go against that CSV, raw CSV files instead of org files. So let me run it. How much time do you think this will take this time? 10 seconds, okay. So it got completed. Yes, got completed. I don't know if you guys can see it. No. So you'll have to trust me because somehow I can't scroll it down. It took about 5 seconds. So imagine this. You are going against raw CSV data that is sitting in the cheapest possible storage on this planet, and you are getting this kind of performance. And that's what we mean by, you don't have to ETL anything. You can kind of create external table on the data wherever you might have and start writing your SQL queries. Let's go. Can you switch me back to the presentation, please? All right. So not only you could do that, you can kind of then hook your LLAP cluster in Azure HDInsight with all of these BI tools. So in this case, I've kind of hooked it into our Power BI. And with Power BI, we support something called direct query capabilities. So let's say if any of the underlying data changed, the data that you're seeing here is not cached. So somebody clicks something, then your query going to go directly against LLAP, and then kind of bring the results. So imagine you're creating all of these very powerful visualization on top of the raw text data or the JSON data or XML data. So with LLAP, I think we want to kind of get to this world where you just ingest and serve. So again, just to kind of recap, so LLAP is a Hive Low Latency Analytical Processing. It can serve queries directly from a Blob store or Azure Data Lake store. Works very well with text, JSON, CSV, TSV, ORC, and Parquet file formats. Super fast performance with text data, which I just showed you. Modern scalable query concurrency architecture. Now, you're going to ask me, what I saw was great, but in our organization, there are more than one users who are kind of touching these systems. How do you perform from a concurrency perspective? And I'll show you some numbers. You can secure LLAP with Apache Ranger and Active Directory. So you can have a very fine-grained role-based access control with respect to your LLAP cluster. So how are we doing it? How it's got to be something. So this is the architecture of LLAP. Your users sort of come to LLAP with something called Hive Server Interactive. This is the component which has two primary functions. One of them is security trimming. So everybody coming from all of these different tools get checked at this layer to see whether they have appropriate permissions or not. And then the second role for Hive Server Interactive is query optimization and planning and all of that. Once you do that, then LLAP daemons are nothing but your cluster nodes. And these nodes run executors. And then these executors can sort of go to the underlying database and metastore and get your data into the cluster. Now, LLAP is a caching technology. And when we say cache, it's just not the DRAM that we think. It's also the local SSD of the cluster. So again, I told you about this model where our compute and storage is separate, right? So your permanent data always lives in either Blob store or Azure Data Lake store. But once you read that data, we store that data into either DRAM and also into the local SSD that cluster has. So for example, the case that I was showing you, I was using a VM type D14 VM. And D14 VMs comes with a 112 gigabyte of RAM plus 800 gigabyte of SSD. And if you combine that 800 plus 112, it's quite a bit of a local cache pool that we have. Now, the other thing that we do in this architecture is we also cache the metadata, because one of the things that we learn in the cloud is that everything is remote. Even your metastore is remote. And so sometime you were getting bottlenecked on just checking with the metastore. So we also cache metastore there. And so if you think about this caching, and we call it intelligent cache, so if you do not have any data in the cache, it's going to go to the underlying store, that may be ADLS and Blob store, and bring data to SSD and DRAM. And all of this tiering, LLAP does automatically, so you don't have to do any kind of a cache management. But one of the things which is unique with LLAP, which is not there in any other engines in the space, is around its ability to react to the changes to the underlying data store. So let's say in your data lake store or a blob store, you receive a new file, new CSV file or a new XML file. If this was a Spark, you have to invalidate that cache yourself. Okay, so you are responsible for invalidating the cache because you need to know whether some new data has come or not. In this case, when you write that select query, the LLAP is going to check with the remote store, and it does lightweight check. So it does check on just on a date modified, for example, right? It's going to go do that lightweight check, and if some data is changed, then it's going to kind of load that into the memory. So thereby, you are always kind of working with the fresh data, and you are not in this business of kind of managing your cache. But when you say, I'm very, very fast, people always ask questions like, then faster than whom, right? It's always relative in life. So does it here. So at least in HDInsight, we have many great engines, and we thought we're just going to kind of run a performance benchmark. So we used 3 engines. One is LLAP, of course. Then we use Spark, and then Presto. And we ran a drive data set from TPCDS, and we ran 45 queries. Now, the reason why we choose 45 queries and not all 99, because all of these engines could run only 45 queries without any modification. LLAP was able to run all of them, but there were engines such as Presto was not able to run those queries. So we picked only the queries which everybody was able to run without modification. And so here are the results. So as you can see, and then again, different permutation and combination, right? LLAP with cached data, LLAP with uncached data, org file format, text file format. With Presto, we picked org, and with the Spark, we picked Parquet because Spark likes Parquet. So of course, LLAP was the fastest among all of these engines, as you can see there. But what was most amazing for us is to see the LLAP with text was equivalent to what Spark with Parquet, which is amazing if you think about it, And so then, 1 terabyte is fine, but then we also ran the drive TPCDS benchmark at the 100 terabyte scale for all the 99 queries. Again, interesting thing there to call out is that, one, we were able to run all of the queries, which is amazing if you think about it. These are not a very simple query. These are very, very complex queries. 41% of them came back within 30 seconds, and 71% of them came back under 2 minutes, so which is amazing if you think about it. Now, do not trust us on any of these numbers because you never know what different vendors talk to you about. All of these kits are publicly available on GitHub. We recommend that you guys can go ahead and run these tests. Again, all of these tests were done on our default configurations. We do not recommend changing the default configuration because our default configurations are our best configurations. Now, the next question comes in concurrency because with Hadoop-based systems, the concurrency has been a traditional, the challenge. 1 or 2 users are fine, but if you have, the 50 users or 100 users in the organizations, well, you have thousands of users, but 50 users going to be concurrently accessing the system. How should you think about the concurrency? So again, we ran the concurrency test. In test 1, if you think about the TPCDS queries, there are 99 queries. In a test 1, we ran them in a serial fashion. So ran first query, and then waited. Not waited, but let that query finish. And then the second query started. So we ran them in a very serial fashion. In a test 2, we ran 2 queries at a time, meaning that concurrency equals to 2, and we are running 2 queries at a time. All the way up to test 7, where we ran 64 queries at a time. And then max concurrency on this cluster was set to 32. Of course, you can set it to much higher, but we set it to 32. And our goal with this test was to finish our workload as soon as possible. So we wanted to run all the 99 queries as fast as possible. So here are the results. So if we ran 1 query at a time, we finished our workload in 1,648 seconds. But if we ran 2 queries at a time, it was 966 seconds. So it got better. Then it got even better with concurrency equals to 4, all the way up to the concurrency equals to 32. Then started creeping up back again a little bit. And this is because, again, as I said, max concurrency on this cluster was set to 32. And then after that, the queries were queuing up. Again, from a concurrency perspective, in theory, you are limited by number of nodes that you have in the cluster. So you can kind of keep adding the nodes and achieve higher degree of concurrency. But of course, there is a limit to everything, right? HS2 will start having issues at some time and whatnot. So if you are in a scenario where you need a very high degree of concurrency, let's say 500 concurrent users or more, again, you may want to be augmenting some of this with a OLAP or a queue-based technology, maybe at scale, maybe Druid in future. But if you want to have that level of concurrency on this system, some of our customers actually bring multiple different clusters on same data and metadata. So you get like a different endpoints for sure. But again, you are going against same data and metadata, security policies and all of that. But then you can get a very high level of concurrency as well. So then, if we think about these 3 engines, LLAP, which is interactive query, Spark SQL, and Presto. So this is a little bit of eye chart in terms of what did we see with those tests. There are many things, and I think I'll leave these slides so you can potentially read that. But a couple of things those are very important to highlight is around this idea of intelligent cache eviction, so that data is changing in the underlying storage, and your ability to react and not do anything and still get the fresh data is kind of a very interesting. And then the query concurrency. Again, we often serve these large organizations where concurrency is kind of a big factor. So those are the key pieces, but I'll leave this slide for you guys. Now, so how much is this thing going to cost me if I were to run this in our organization? And again, this is just a one use case. We provide an Azure calculator, and you guys can come up with depending upon what your scenario is. But let's say a typical case where your data set is 100 terabyte, and you have about maybe about of that is 600 gigabyte is like a hot data that you need to have a very fast results on. And so in this case, we use 6-node LLAP cluster, which will give you about 672 gigabyte of RAM and 4.68 terabyte of SSDs, 6 concurrent sessions. You could potentially run like 1 million queries in a month, may run more. It will be about $9,000 at the list price in US dollars. But again, this will depend upon your scenarios and what you need to do there. Questions? Mm-hmm.
Assuming that you wanted the best performance for your demo, why didn't you choose a data lake as a basis?
Yeah, so the great question. So why didn't I choose? So I think there are 2 questions. So one is, why data lake store versus Azure Blob storage, and is the performance is the key criteria to pick either one of those. So majority of our customers pick ADLS versus Azure Blob storage if they need, let's say, hierarchical file system or a file and folder level ARCLs. So that is the main decision point. From a performance perspective, both blob storage, especially with the introduction of limitless blob store, where you have no limits on bandwidth and no limits on storage, the performance is now on par from a data lake store and a blob store perspective. It used to be the case when the blob store has these very strict limits, but now those are gone. That is not the case anymore.
So, how do you handle multi-tenancy in terms of resource sharing?
Yeah, that's a great question, and I'm out of time. So if they kick me, then we can have this discussion outside, but that's fine. So multi-tenancy in the cloud is kind of very, very easy. One, LLAP has a preemption in a sense that if you have a query that can be served very, very fast, it will serve it very, very fast. But also, you can give individual teams and groups their own clusters sitting on same data and metadata. Thereby, that resource sharing burden, you kind of push down to them, and they get a lot of flexibility. I think on-premises systems, typically there is only one large monolithic big cluster, and a lot of departments and users kind of come to that same cluster, and a lot of contention happens. So in the Xbox case that I was mentioning, 5 petabytes of data warehouse, but then there were hundreds of clusters for all of these different users and personas and whatnot, and that resource contention issue kind of goes away. But the traditional means are available to you the way you would use them on premises. All right, no more question. Thank you very much.